Welcome to The Explainer. Today, we're basically going to become librarians, but for all of life on Earth. I mean, think about it, millions and millions of animal species. It sounds impossible to organize, right? Well, scientists have a system, and we're going to walk through it together.
I mean, really, where do you even start? You've got this incredible, beautiful chaos of life all around us. How do you possibly begin to sort it all out?
Well, the answer is a system called taxonomy. And the best way to think about it, really, is as this giant library of life. Every single animal, I'm talking from the tiniest little mite to a massive blue whale, gets its own specific spot on the shelf. It's like a unique address that tells us its story and, crucially, how it's related to everything else.
Okay, so the first big split in our library, the most basic fundamental division, it all comes down to one simple question. Does it have a backbone? That's it. And believe me, that one little feature splits the entire animal kingdom into two huge, and I mean really unequal groups.
So first up, we've got the invertebrates. These are the animals without a backbone. And get this, they are the undisputed rulers of our planet. They make up over 95% of all known animal species. That is just staggering. They were really life's great pioneers, and their simpler body plans meant they could adapt and thrive in pretty much any environment you can think of.
So you might be wondering, how do you even hold yourself up without an internal skeleton? Well, let's look at the biggest group of invertebrates, the arthropods. They came up with a brilliant solution. Just build your armor on the outside.
Yeah, their whole success story is built on this tough exoskeleton. It's like a custom-made suit of armor that gives them protection and structure. You combine that with a segmented body and those super important jointed legs for moving around, and you've got a winning formula. It's why insects, spiders, and crustaceans are just everywhere.
But, wearing your skeleton on the outside isn't the only way to do it. The mollusks, they took a totally different route, and it was just as successful. These are the soft-bodied builders of the animal kingdom.
Their solution for being, soft and squishy is absolutely ingenious. A lot of mollusks, think snails and clams, they have this special organ called a mantle. And what it does is it secretes a hard shell made of calcium carbonate. They literally build their own mobile homes for protection. How cool is that?
Okay, so we've spent some time with life without a backbone. Now we're making a huge leap. We're moving to a totally different wing of our library, to the phylum that has some of the most famous animals on the planet, including, yeah, you guessed it, us. This is the phylum Chordata.
Now here's the wild part. Every single member of this group, it doesn't matter if it's a weird little sea squirt or a person, shares this exact same fundamental body plan at some point in its life. It's like a master blueprint that includes a flexible support rod called a notochord and a nerve cord that eventually becomes the brain and spinal cord. Okay, but inside this big group of chordates, there's an even more famous subgroup, the vertebrates. And in these animals, that flexible notochord from the original blueprint gets a major upgrade. It gets replaced by a whole series of interlocking bones, the vertebrae, that form a strong protective column around that super delicate spinal cord. And that, my friends, is the backbone.
And the backbone was an absolute game changer. I mean, it allowed for bigger bodies, more powerful movement. It basically set the stage for vertebrates to crawl out of the water and begin to conquer the land.
Of course, that story starts in the water, with fish. They pretty much perfected life underwater, right? They've got gills to snatch oxygen right out of the water, fins for steering, the whole package. They're also what we call cold-blooded, and that doesn't mean their blood is actually cold. It just means their body temperature changes to match whatever the water around them is. But this brings us to one of the biggest challenges in the entire history of life. How do you make the jump from the ocean to solid ground? I mean, suddenly you've got to deal with gravity in a whole new way. You're going to dry out, and you have to breathe air. So, how in the world did vertebrates manage to pull that off?
Well, the answer is pretty incredible, and it lies with the amphibians. Their name literally means two lives, and that's because they live out this entire massive transition in their own lifetime. Think about it. As larvae, like tadpoles, they're basically little fish. But then they go through this insane transformation, a metamorphosis, and grow lungs and legs to live on land. The catch? They still have to stay close to water to lay their eggs.
So who came next? The reptiles. And these guys were the first vertebrates to truly cut the cord with the water. Their secret? A couple of killer innovations. First, they developed dry, scaly skin that keeps them from drying out. And second, and this is huge, the amniotic egg.
It's basically a self-contained little pond with a protective shell that let them lay their eggs right on dry land for the first time. All right, now we get to the final two groups of vertebrates. Both of them actually evolved from reptilian ancestors, and they developed this powerful new tool, a metabolic superpower, really, that gave them a massive advantage. It let them live almost anywhere, from the freezing poles to the hottest equator.
And at first glance, they seem totally different, right? You've got birds with their feathers and flight, and then you have mammals with fur and milk. But they share one absolutely revolutionary trait. They're both warm-blooded. That means they can generate their own body heat from the inside. And this ability is incredible. It lets them stay active when it's cold and gives them way more stamina than their cold-blooded relatives.
So, wow, what a journey through our library of life, right? We've gone from the jam-packed invertebrate shelves all the way to the evolution of the backbone, that crazy jump to land, and the rise of warm-blooded animals. It really brings our whole tour down to one last, very personal question.
So after all this, where do we fit in? What's our address in this massive library? Well, we are vertebrates. We're in the phylum Chordata. And more specifically, we belong to the class Mammalia. Yep, that means we share that warm-blooded engine, we have hair, we produce milk, and that connects us to an amazing family, from tiny bats to giant blue whales.
And in the end, that's what this is all about. This classification stuff, it's not just about memorizing a bunch of long names. It's about learning to read the story of life itself. It shows us these deep, ancient connections that we share with every single other creature